Hello everyone. In this demo, I'm going to show how to use the F5 Distributed Cloud to interconnect multiple sites using dedicated private connectivity. In this demo, I use an application that's distributed onto multiple sites. For this example demo, I'm using the sample app called Arcadia Finance. It's an application that we like to use here at F5 because it's an example of a modern app and it runs in multiple locations concurrently. In this case, we have the entrance or main ingress point to the application running in AWS, and we can see that with the blue tiles. This app also has various components, like the API portion of the app to do money transfers. That's running in Azure. And we also have the Refer a Friend module that's running, again, in AWS, but it's a little bit different. It also accesses data all the way down in the on-prem database. All of the dependent modules, API and Refer a Friend, access the on-prem database to pull stocks data, money transfer accounts, as well as to keep a list of friends that are invited. What are the steps involved in the orchestration feature itself? Well, first you'll need to extend the on-prem network to a colo space. Next, you'll need to create or provision an express route circuit for Azure or a direct connect gateway in AWS. What else happens with this feature? Well, once those circuits are provisioned and configured in the Distributed Cloud console, you no longer need to configure any routing on the sites. And this gives Distributed Cloud the control to be able to manage not only the routing across your multiple sites, but also gives the ability to introduce firewall policies. This is important because you can allow or limit the amount of traffic that runs between different sites. For this specific demo, I've configured layer 3 routing with private connectivity, and I'm connecting my on-prem data center with a 10200 CIDR block going to my AWS site, which is using 10100, and also in Azure 10101 CIDR blocks. All of these are interconnected with BGP peering, and Distributed Cloud is managing all of those routes, except for the on-prem location. All right, let's take a look at how this works in the console. Now let's configure the Azure VNet site. Enter the name, the resource group that you'd like for this to appear in your subscription, and you can configure which regions you'd like for this to be deployed in. You can also choose to use a new VNet or create a whole, join your existing VNet. The important thing I want to call out here is when you deploy this to use private connectivity, you're going to need to ensure that you use two interfaces, and that's either on the recommended region or you can specify your own specific region if you find that better for your deployment scenario. Once you've got your two interfaces selected, go into the two interface setup, and here you can access the network firewall policy. I'm not doing it in this demo, but if I wanted to restrict access to specific traffic on this site, I'd be able to use a firewall policy here. And one of the neat things that we can do with policies in Distributed Cloud is we can configure which subnets are allowed access and which are not. We don't simply need to do a network ACL. We're talking about tagging subnets, and subnets that are tagged can be allowed or denied based on the firewall policies that we set up in Distributed Cloud. For now, we'll just continue with the rest of the configuration. Now let's take a look at the express route configuration that we've set up. For this part, I'm going to access a site that I've already configured in Distributed Cloud. Here we can see under the advanced options, there's a VNet type. To support express routes, we're going to use the hub VNet configuration. And here we'll define all of the subnets that are available to the routing. In this case, two of the subnets have been automatically configured by Distributed Cloud, and the third one, manual, is one that was already existing in my Azure subscription. If you want to add a new VNet, you just need to go in, edit the resource group, use an existing name, and decide whether you want Distributed Cloud to route to it or not. In this case, automatic routing was great. And the part that's interesting and I find really important here is the label for the VNet peering. Labels allow you to configure and control the firewall policies. So if I were to add a label here, I could allow this individual subnet access to a particular application. Continuing, it's now time to add our express route configuration. Here you're going to add a new connection, and here I've already got one added. The options that are important here are you can either use a circuit in the same subscription that the CE site has been deployed to, or you can connect to a circuit in another subscription. If you're using a circuit in another subscription, you'll need to add the authorization key in order to map to that circuit and have access to it. And that's really all that's needed in order to get the orchestrated setup complete on Azure. Next up, we'll go over to our AWS VPC site. On the VPC site, if we take a look at the configuration, we'll see where Direct Connect has been configured. If we go down, notice that I have the two interface gateways selected. Here we can choose firewall policies, and under the advanced fields, we can add in the different static routes. Here I've added the static route specifically for individual subnets that I want to extend the distributed cloud routing solution to, but this is not mandatory. In fact, you could make this automatic and distributed cloud would add the necessary entries to the route tables belonging to the subnets in AWS. Continuing, we'll now enable, under the advanced configuration, our Direct Connect circuit. There are two modes for Direct Connect, standard VIF and hosted VIF. In this configuration example, I'm using the standard VIF mode, but I could be using the hosted VIF mode, and I would use that in fact if I had, for example, my organization already using the Direct Connect route or circuit for other purposes and other business units. In that case, a hosted mode makes more sense. In this case, however, if you're setting this up from scratch or from the very beginning, you could use the standard mode to automate some of the configuration for routing to the circuit. And that's all that's needed with AWS. Now let's take a look at how the application is configured. There's very minimal configuration needed to support this application when directly routing. Most of the work is at the routed orchestration part. In this case, we take a look at the origin pool. I'm just using a static IP, and this IP points to my ingress point in AWS. If we look at the load balancer config, you can see that my origin pool is defined, and the only feature that I'm using with my load balancer to make this ingress available to the internet is to advertise it publicly. And that's really the only service that's needed in Distributed Cloud to support the app. Using a web browser, we're able to access the app, and I'll go ahead and log in. Once logged in, we can see that the various tiles have all been loaded from the apps running in different locations across the network. If I go in and I put in an email address to refer a friend, you can see that the module that's running in AWS makes a call out to the backend to log the email address, such that I cannot refer the same friend twice. So if I go back and try to sign up the same email address a second time, I'll get an error message because the database was able to show that that email address had already been registered. So if we go back over to our HTTP load balancer and just look at the monitoring, we can see what requests have come through the internet into the main app. Now, if we go back and log into our various microservices running in our different sites, we can see that I've got the main app on AWS, the API app in Azure, and the database on-prem. If I open up a shell to my front end running in AWS, and I use the hping3 utility to emulate app traffic going to the API, we can see the router address at each hop along the connection so that you can see that my private routes are working and layer 3 routing this all the way through to the destination in the other cloud. Similarly, if I go and open curl, we can take note that the server in the response is my direct end server Nginx. If this were via an HTTP LB proxy, you would see something like Volt ADC here if I had an HTTP LB configured, but instead I do not. And you can see that I've got the response directly from the site. Similarly, I can show you here on Azure. If we take a look at the IP address, 10.101.1.5, you can see that that corroborates with the IP that I just connected to previously from my AWS workload. Similarly, my on-prem IP address of 10.202.137 is directly available from the API and the refer a friend workloads being able to connect out directly to the on-prem database. This is a pure layer 3 routed solution using private connectivity. Lastly, if I access my workload running in AWS and I call out to the database, emulating a connection from the refer a friend module to the database, we can again see that I'm getting a direct response from my database with the server tag of Nginx, and you can see the file data there. I hope you've enjoyed this demo for showing how to set it up. If you're interested in more information about this, I invite you to visit our product site online at f5.com/cloud/products/multicloud transit. Thanks for watching.